So good morning, everyone. Today I'm going to talk about some recent work that we did focusing on understanding and mitigating online harms using some artificial intelligence models. So before starting my talk, I would like to note that some content included in the slides might be offensive or disturbing. So this is mainly because we are dealing with the problem of hate speech. So the slides contain some examples. We do not, we don't want to promote this content. However, we show them to better articulate the gravity of the problem. Okay, I would like to start with a brief history of the internet. So basically, at the beginning of the web, things were pretty simple, right? So we had like static web pages where you basically can disseminate information without much interaction. But we also had more interesting things like, communicating with other people via tools, simple tools like MIRC and so on. But we didn't kept, we kept improving our services that are available on the web and so on. And we introduced more useful services, right? So we have, for example, Google, Facebook, or Twitter. So in general, the internet became more social, right? Now, looking at a view of what I call modern web ecosystem is we observe that we have a conglomerate of various types of social networks and various services. For example, on the top, we have, typical social networks like Facebook, Twitter, and so on. We have multimedia-oriented networks like, most of you, I'm sure, are aware of TikTok, YouTube, and so on. We also have messaging platforms that I know, for example, in Brazil, WhatsApp is very big and so on. And we also have a rich news ecosystem. Now, this ecosystem is great, right? It basically improves our lives at multiple aspects. So, for example, it improves our communication. It allows us to acquire knowledge. It also allows us to do other stuff like shop, get entertained, and so on. Like, imagine how the COVID-19 pandemic will be without all these services. Now, as with most things in life, the same coin has two sides. So basically, the same web ecosystem can amplify some problems. For example, it can amplify mis or disinformation, fake news. So previously, during this week, Fabrizio and Giusara covered extensively the problem of fake news and how this ecosystem is promoting, how easy it is to promote this kind of content. But we also have some other problems like, for example, hate speech and also online manipulation. So for the context of this talk, I will primarily focus on the problem of hate speech. So in general, in my research, I have three main goals. So the first goal is to basically understand these issues and how they affect the real world. So the second goal is to basically design tools and techniques to identify instances of these emerging problems. And finally, the third goal is having identified instances of this problem. The question is how we moderate and how we intervene to prevent these problems. So during this talk, I will primarily focus on the second part, which is basically how we can use AI tools to detect hate speech. So hate speech is an everlasting problem with real-world impact. So why it's an everlasting problem? Mainly because of various reasons. One of the reasons is that we don't have, a robust definition of what constitutes hate speech, and also there are a lot of challenges in identifying hate speech. For example, you have things that might be shared on text and images, so it's hard to detect instances across these modalities. And also the other problem is that sometimes it's a little bit subjective, if it's hate speech or no. And again, hate speech has a real-world impact. For example, back in 2018, so Robert Bowers, that was basically radicalized on Gap, a network that was sharing a lot of anti-Semitism, basically went ahead and perpetrated the deadliest attack on Jewish community in the US. So it's important to identify hate speech and mitigate this problem. But the question that we ask here is how can we detect hateful content across text and images? So that's the focus of the work that I will present today. So in general, the plan for this talk, I will briefly give you the main idea of some AI models that use this contrastive learning paradigm. So I will explain what that is. And then I will very briefly give you the idea of two very recent works that we did. So the first is on detecting anti-Semitic and Islamophobic content using these contrastive learning models. And the second work is about understanding the evolution of hateful memes using the same model. And I will conclude with some thoughts about the future. So in order to understand contrastive learning, let's revisit this traditional supervised learning paradigm. So in the traditional supervised learning, what we have is basically a training data set, which is labeled. So essentially, you have a bunch of images that are associated with a specific class. And then you basically a very simplified visualization is that you basically train a model. And then the prediction is that you given a set of images that the model have not seen, the model tries to predict if an image shows a cat or a dog, etc. So here, given the image, it just classifies what animal is shown in the image. So on the other hand, contrastive learning is basically a self-supervised paradigm. And what that means is that you essentially do not have labels. So the only thing that you have is basically positive and negative pairs. For example, in this case, the training data set is as follows. You have images, again, in the same examples, but you only have which images are similar and which are not. For example, the two images that are cats are similar. The images with cat and dog are dissimilar. So this is the training data set. Basically, after you train the model, then the prediction is given two images. You can basically say these two images are similar or dissimilar. So that's the main idea of contrastive learning. So you are basically contrasting samples from the training data set without giving more information of what actually the images are. So what are the advantages of contrastive learning? So basically you learn from unlabeled data. So labeling data is hard and sometimes it requires a lot of resources. So that's a good thing for contrastive learning. And the other thing is that since the model is not trained on a specific task, you can basically reuse it for multiple other tasks. And basically, why is that? It's because basically the model training mimics how humans learn by contrasting similar and dissimilar experiences or samples. Now, for our work, we used basically a specific model that was released by OpenAI, which is called OpenAI Clip, which basically uses this contrastive learning paradigm to connect text and images together. So what they did is the following. So they created a huge data set of 400 million image-text pairs from the internet. And basically, this data set includes an image and a text that describes what is included in the image. Okay. And then what they did is that basically they have a text encoder and an image encoder. So I will not provide details of how these text and image encoders work. So there are some state-of-the-art text and image architectures, encoder architectures, but you can think about it as simply a big model that takes as an input a text or image, and it just represents the image and the text as a multi-dimensional vector. So what they do here is that basically they split the dataset into batches, and for each text and each image in the batch, they use the text and image encoder to extract these embeddings. And basically after they have these embeddings, so for example, T1 to Tn is basically all embeddings from the text in the same batch. And I1 to In they are all the embeddings of the images in the same batch. And then what they do is that they basically have a contrastive loss function, which basically tries to minimize the distance between the embeddings of the text and image pair, because you know which text and image pair are similar, and maximize the distance for all the other pairs that are not similar in the same batch. So when they do this, and imagine if the model is trained on a huge data set, what eventually happens is that the model learns general knowledge from natural language, because the text encoder is simply is based on natural language. So after you train this model, so what you can do later is basically you can perform zero-shot classification. So what that means is that basically you can create your own custom classifier. So what you can do, for example, if I want to detect objects or animals, I can define a set of classes, for example, plane, car, dog, bird, etc. And then I can create what I call prompts, you know, a photo of a plane or a photo of a car. So these are the classes essentially. And then what you do is that you use the text encoder to obtain the embedding for the class that you want to, for the classes that you have. And then you obtain the image embedding from the image encoder. And then you simply select the class that has the closest embeddings. So the question here is, how can we use this model for studying hateful content? So basically here, we use two main properties. So the first property is basically assessing similarity of content irrespectively of modality. For example, as I said, the model just embeds images and text to the same high-dimensional vector space. So by simply obtaining the embeddings, and for example, here I show simplified 2D visualization, you can see that how we can use it to identify similar content. For example, the text cat will be close to an image showing a cat, the same with a dog. On the other hand, if you have something that is, you know, offensive, it might be, you know, very far from benign things. And it can also use to basically connect hateful text that is also represented via images. So that's the first property on how we use it. And the other thing is that basically these embeddings encapsulate some relationships that are similar to relationships that exist in word embeddings for people that are familiar. But I will explain now how they work here. So basically there are two types of relationships. So the first one is, we call it visual semantic regularities. And what it means is the following. So let's assume that we have this image of this hateful symbol, which is basically the anti-Semitic happy merchant. So if we use, let's assume that we have a very big data set of images, all the images that are shared on Twitter or 4chan and so on, okay? So we can basically do the following. If we obtain the embedding for the happy merchant meme, and then we do an addition with an image showing Donald Trump, and then we search. So we obtain the summated embedding, okay? So we sum the two embeddings, and then we search which is the most similar image to the summated embedding. You will get an image something like this. So basically what happens is that both, so the new image fuses both modalities, okay? In a similar manner, you can do subtraction, right? So you have there a model, an image that includes the happy merchant after the line, then you subtract with the embedding from the happy merchant, then you get an instance that don't have happy merchant, okay? So that's the main idea. Similarly, since clip embeds text and images to the same vector space, you can do it across modalities. For example, if you take the Pepe the Frog, the embedding of Pepe the Frog, and you add it with the embedding of the word Nazi, and find the most similar image, you will get something like this. And similarly, you can do subtraction. Pepe the Frog with CNN minus CNN News, you get Pepe the Frog without CNN News, okay? So basically, in the works that I will show later on, you basically use these two properties that I showed right now just to investigate it and identify hateful memes. Okay, first I will start with the first piece of work. This work focuses on identifying anti-Semitic and Islamophobic content using this specific model. So this paper will appear at ICWSM 2023, and is basically led by Felipe González Pizarro. So this paper has basically a very simple idea. So the idea here is that, so again, we have, here we have, if you have a text query, which is basically something benign, like cute cat sleeping, and then you search for all images on 4chan, you will get something, some images like the ones depicted here. And the number below, it basically shows the cosine similarity between the embeddings of the text and the image that is shown. So the idea of the paper is the following. If we use some text queries that are hateful, that disseminate hateful ideology, the resulting images will be hateful as well. So for example, here, this is based on the same, this is a real example, which basically we tried with the text query Gods and Jews, and you use all the images shared on 4chan for a period of 1.5 years. And basically you can see that the most similar images actually capture the same semantics without, having the same text or so on. For example, the model was able to associate the Holocaust and Hitler with this text query without explicitly mentioning Hitler and so on. So what we did in this work, we basically identified a list of anti-Semitic and Islamophobic phrases. And how we do that, we basically used Google's Perspective API to identify toxic content that talks about Jews or about Muslims. And then basically we perform human annotations to actually verify that these toxic posts are actually anti-Semitic or Islamophobic. And then what we did is that we use these phrases as the text queries into clip, and then we identify the most similar images based on these phrases. So specifically, we had 326 anti-Semitic phrases and 94 Islamophobic. And then we collected a dataset of 5.8 million images shared on 4chan for 1.5 years. And basically what we did here is we selected images where the cosine similarity between the phrase and the image embedding is above a threshold. So we did some manual annotations just to identify this threshold. And then to reduce the number of false positives, we keep images with at least n matching phrases. And so at the end, we were able to detect 15,000 anti-Semitic images and 5.5 Islamophobic images. So here basically to select a threshold, what we did is that we extracted through 2,000 images obtained from 10 randomly selected phrases. And then what we did, we basically annotated each image if it's actually Islamophobic or anti-Semitic. And then we varied the cosine similarity threshold and calculated standard metrics like F1, precision, and accuracy. And we figured that the best performance is when the threshold is equal to 0.3. Of course, the problem here is that the model generates a lot of false positives simply because of of the similarity, and simply because it might be similar to the input query, but it's not actually anti-Semitic or Islamophobic. Of course, we compare this simple approach, because it's a simple approach of with these thresholds and so on, with some previously suggested models from the literature, and we observed that this simple approach can increase the F1 score by 0.54, but still the performance is not like you cannot use it automatically to detect hate speech. But it's impressive that this general purpose model was able to perform so well in this very hard task. And then we did some basic analysis of of the findings that we had, because we had all the textual posts and all the posts that included those images. And basically the main insight here is that actually on 4chan, visual hate speech is almost as prevalent as textual hate speech. So that's why it's important to, when we study these problems, to combine both modalities. Okay, let's move to the second part. So the second part is basically focusing on understanding the evolution of hateful memes. So this paper will appear at the IEEE Security and Privacy 2023, and it's a joint work with a lot of people from CISPA in Germany. So the main idea here is that hateful content is not stationary, So something might happen in the real world, and then new hateful memes or instances might emerge. For example, I don't know, something might happen with Bolsonaro, and then new hateful memes are created, right? So the question is how we can identify emerging hateful memes. So for example, for the Happy Merchant case, we can also observe that there are many variants. For example, you have the Donald Trump variant of Happy Merchant, the Pepe variant, and so on. So in this work, we basically ask how can we systematically identify these variants. And how we do that, we using the second property with the relationships of the embeddings that I talked before. So concretely, given a known hateful meme, the main idea here is that we want to identify hateful meme variants and the influencer. The influencer is basically the image or the text that is likely responsible to be related for the creation of the new hateful meme variant. So what we did here is the following. So we basically started with a known hateful meme, which in this case is again the Happy Merchant meme. And basically we use again the clip model to map all the images to embeddings. And then what we do is basically we identify images that are within some thresholds of similarity between the embedding of the known hateful meme and every image in our 4chan dataset. And we set a lower and upper threshold mainly because we want to get, images that are similar, but not very similar. Because if you are very similar, then you are getting basically the identical meme, which is not a variant. So that's the main idea for identifying variants. And then basically, once you have, a known hateful meme and the variant, then you use the same exact methodology to potentially identify the influencer. So what we do here is basically we first take the embedding of the known hateful meme, and we add it with the embedding of each image in our 4chan dataset. And then we calculate the cosine similarity between this addition and the embedding of the hateful meme variant for each hateful meme variant that we identified. And then we simply select the image from the dataset that has the highest similarity. So that's how we identify the influencers. And we run our methodology using the happy version meme. We identified 3.3 thousand variants along with our influencers. And then we perform a manual annotation just to test how this thing works, how well it works. So basically, we extracted a random sample of 100 variants. And then manually, 3 authors checked if actually these are hateful variants and if the influencer is actually the influencer. So what we found out is that 78% of the identified variants are correct, but for the influencers, only 53% were correct. So it's much harder to identify the influencers because you don't know exactly which image is responsible for the creation of the new meme. Now we can do basically the same thing, but instead of doing it with image and image, we can do it with image and text. So for example, you can identify hateful meme variants by taking a known hateful meme and doing addition with some text, For example, if I want to identify a happy merchant variant of Brazil, I might do a known hateful meme plus the embedding of Brazil and see which is the most similar image to see if there is indeed, if there exists a hateful variant for Brazil. So here what we did, what we use here is the following. So because our 4chan dataset had also text information about what people were talking via text, we use basically natural language processing techniques, specifically named entity recognition, to identify entities that are mentioned in the text. So we created this big list of entities that are mentioned on the text, and we treat it as the textual influencers. So this is static, they are known. And then we select the known hateful meme, which is the happy merchant, and we do exactly the same methodology as before, with the only difference that in the summation, we just weight more the textual influencer. So we do a weighted summation of 0.8 for the textual influencer and 0.2 for the image, mainly because our manual checks showed that basically if you don't provide more weight to the text, then you don't actually get variants that are intuitively correct. So basically, we ran this methodology with on 4chan, and basically the results are pretty depressing. So basically, for most of the textual influencers, we were able to find specific variants of this hateful meme that basically encapsulates this hateful rhetoric. For example, we found instances for Hillary, Trump, Hitler. For countries, for most of the countries, we are able to find their own instances, as well as other things like organizations and so on. Another thing that we tried is basically try to understand how these things are shared over time. And why this is important? We feel it's important because it can give us some insight into hateful orchestrated campaigns. For example, some people creating a meme, a new meme, and then they spread it online on a large scale. So here what we did, we simply plotted these hateful variants and how they appear on our dataset. So the main finding here, for example, is that the Hillary variant is shared, because this is a dataset during the 2016 elections. So the Hillary variant is shared, it's the blue line, the blue area here. It's shared over the entire year, whereas, for example, the Trump variant is shared only on a specific day, which is related to when Trump made an attack to Syria, and people were calling him like that he's controlled by Jews and that he's a Jew, and they created this meme and they were shared on 4chan. Okay, now to summarize, Clip is we played with Clip basically, and it's a very powerful model. It can play a role in identifying hateful content, and also it can be used to study various problems using these relationships that exist between the embeddings. And yeah, we envision that all these tools that I showed today can potentially be used along with human moderators. So basically, you can use this model to flag a lot of content and then present it to human moderators that can actually take action. Yes, and can be used to identify orchestrated hate campaigns. Okay, now looking forward. Is this problem solved? I don't think so. I mean, we are still at the beginning, and I think it will become even worse. And why is that? This is because we are observing again a substantial shift on what is happening on the internet, right? So there are two things that are basically started getting increasing popularity. It's first the use of AI models for recommending content. For example, how many of you are using TikTok? Yes. So TikTok, everything is based on the recommendation algorithm, right? You go to the For You and you scroll, and everything is recommended, right? And the other thing is that the increasing reliance on AI models for generating content. For example, have you played with ChatGPT, Stable Diffusion, DALL-E, and all these things? Things will get even worse from here. So there are many challenges that arise. For example, there is a need to study how algorithmic recommendation systems are potentially driving people towards problematic content, and also how prone these AI and generative models are in generating, unsafe content, essentially. So for the AI recommendation systems, and basically what we are observing is a shift from what I call social network-based feeds, which is basically you see what your network shares, like your friends and so on, to AI recommendation-based feeds, which you basically, most of the content that you receive is based on an AI recommendation system, and only a limited number from your network. So this may lead basically to the development of problems like mental health, or it can lead to online radicalization in the cases of, this recommendation algorithm recommends a lot of extreme content and so on. So what we are basically trying to do here with our ongoing work is to basically understand this problem through the lens of donations from real TikTok users. So the main idea here is that so all TikTok users, based on the GDPR, have the right to request their personal data from TikTok, and TikTok is obliged to provide the data to you. So the data includes basically whatever you did on TikTok and so on, what videos you watched, what you liked, what you shared, and so on. So the idea here is if we had a donation system to facilitate data donations, then we can get these rich data sets and then analyze them to understand algorithmic recommendations. And this is important because this data set includes behavioral traces that are otherwise inaccessible. And the other thing that it's important here is basically assess how some mechanisms that are provided by social media platforms, how good they are. For example, recently TikTok started providing these explanations of why you are seeing these videos and so on, but it's unclear how good these explanations are. Or the other thing is basically user feedback mechanisms. For example, on TikTok, you can specifically provide feedback to the algorithm. For example, not interest, which means I'm not interested in this video, so don't recommend me similar videos. But it's unclear how effective these mechanisms are. So I think it's important to study these problems, and basically they are also very relevant right now because the EU is also releasing this regulation, which is called Digital Services Act, which basically calls for audits, and they will hold social networks accountable for these problems. To conclude, I would like to talk a little bit about these generative AI models. So I'm not sure of how many of you are aware of these image-to-text models, but they are becoming super popular. So simply, these models are basically given a piece of text. They can, you can use a piece of text and use this model to generate realistic images. For example, here, if you provide to Midjourney, which is a text-to-image model, this text, high texture quality portrait of a young woman with freckles and crystal blue eyes, you will get something like this, which is, kind of realistic and impressive, I would say. But this opens, possibilities for misuse, right? So people might use these generative models to potentially generate unsafe content. For example, sexually explicit things, disturbing, hateful things, misinformation, political content, images that promote self-harm, and so on. So I think it's important in the future to study these text-to-image models and how prone they are. For example, here there is actually a community on Reddit that basically it's called Unstable Diffusion, which basically use stable diffusion, and they create specifically curated text prompts so that these text-to-image models are basically generate sexually explicit images. So they are misusing these models to generate unsafe content. Of course, these models also provide some filters, which is basically, it's called the safety filter, which basically proactively identifies if the image is unsafe, and it doesn't show it to the user. But the problem is that these filters are they miss a lot of things. So even for unaware people, if you go there and you put a clean prompt, it's likely that you will end up with something that is unsafe. So we did some preliminary work. Basically, we measure how prone are text-to-image models in generating unsafe content. And actually, we use two types of prompts. The one is what we call clean prompts, which is basically something that is not related to any unsafe content. It might be like a photo of a woman or something like this, so very, very benign. And we observe that there is a non-negligible chance that you will get something that is unsafe, specifically 0.5%. Whereas on the other hand, if you have prompts that actually talk about unsafe concepts, like you include, for example, explicit words, or try to generate images about politicians and so on, you can actually achieve that with easily. And we observe in our preliminary analysis is that 15 to 50% based on how the dataset is constructed, it can lead to unsafe image generation. So I think it's an important future avenue for future work. Yeah, and there is a need to basically implement better safeguarding tools that basically do not allow users to generate this unsafe content. Yeah. So that's pretty much what I had. I would like to conclude my talk with acknowledging all my colleagues that basically helped with the work that include that I presented. So most of the credit goes to them, and I will be glad to take your questions.
Thank you very much, Savvas. Very, very interesting talk. Oh, we have a question. I can see at least 5. Okay. Let me start with the one who didn't make the question in the last session.
Hello, thank you for the presentation. I would like to ask a question about the last topic of the AI-generated images. Yeah, it's about the unsafe images you said that could be generated. I've been following on Twitter and other social media recent problems that people have been having with the use of image of real people or even people that don't really exist, but to create sexually explicit content without consent and spreading it as even as a form of making money. And do you think there's a way you can, governments or, I don't know, someone can regulate this so that right now, while the research doesn't go on and doesn't find a way to stop it, that we can reduce or we can make people accountable for what they were doing?
Yeah, actually, that's a very good question. And basically, currently, yeah, there are no, governance that helps with this problem. But what I know for sure is that right now, for example, they are trying. So it's a slightly different problem, but right now they are trying to make accountable the designers of Stable Diffusion, because what it happened is that they, for example, they obtained images to train the model without consent. Of course, it's something different, without consent from the creator, and then basically they sued them for this. But yeah, to go back to your question, is basically there is a need to have better policies to prevent these things, which currently we don't have. And because this is also emerging technologies, people also don't really understand, So we also have to have more experts in these, governance bodies.
Thank you for the presentation. And my question is, what is the odd to this kind of AI become like a new Big Brother from 1984, like censoring everything and hateful and non-hateful content without any barrier, Mm-hmm. And do you think the human moderating is enough?
I think we are still far from using this model with these models without any human supervision. So currently, I think it's important to keep humans in the loop, and I envision this being as a system that basically uses both the AI and humans to moderate content, because the thing is that these models generate a lot of false positive, and then you will have issues with, why my benign post is moderated, and this is against free speech and so on. So yeah, I think I don't know how things will be in the future, but right now I think it's unlikely that social networks or services will just unleash this model on its own. Yeah.
Thank you a lot for your presentation. And in that case, as you said about non-human moderation of hateful content on social media, we nowadays have like Me6 or Nightbot on Twitch and Discord that they do that job, but only with texts. Do you think we can actually optimize that model that you made with Clip, for example, into a bot we could at first try on Discord, for example, or 4chan and Reddit, to try to filter the image content by its variables to limitate the hateful content?
I mean, you can definitely use it, but you will have to do manual work from the moderators. You can use it to flag potentially hateful things. For example, you can even do more advanced things, like if you are because each Discord community might have its own norms. You know, they might not allow specific things. So you might even construct specific prompts, like for example, image showing XX that is prohibited or something like this, and then you can reuse the same thing to basically flag images or text that are, they are sharing the same thing, but irrespectively of if it's an image or a text, and then you flag it, and then human moderators can test it, But it's definitely applicable, because the thing is that the model is general, it's general, so it's trained on internet data, a large data set, so you can apply it in many platforms and so on.
Hi, Savvas. Thank you for the lecture. It was very informative. So my question is on hateful meme variants that are memes that are hateful, but, use the meme format that is hateful, but in a non-hateful way. So let me give you a quick example. Like, let's say we use the happy merchant meme, but to use in like an example like evil mother-in-law. I love my mother-in-law, but in this case, let's say the evil mother-in-law case. How do you guys today filter out, the hateful memes that are actually hateful, or hateful memes that are used in a, in a non-hateful way? Do you use in moderators, or are we up to the point where you can algorithmically differentiate those memes?
Yeah, that's a very good question, and that's why I said at the beginning it's very hard to detect hate speech because of the, the subjectivity, or this thing that you basically hateful things are used in, non-hateful context and so on. But right now, I think we are not into the point to identify all these fine-grained things. So, for example, in your simplified example, what you will do, you will basically, simply because it has happy merchant, it will be flagged as, hateful. And there's also a debate here, is it hateful or no? I mean, if I present this to a person that's coming from Jewish community, even if it's, it's funny or something, it includes the anti-Semitic symbol. So for him, it might be offensive, So yeah, so it's a great, there is a lot of debate about this. So.
Hey Savvas, thank you for your presentation. So my question is related to the role of TikTok on things related to what you presented. So at the end, you mentioned that TikTok is one of the social media platforms that people basically can delve into more extreme things. So you presented 2 papers on how to detect hateful memes and variations on images. So my question is, currently, what do you think is how big a role does TikTok play on spreading hateful memes, and what do you think is needed on technique-wise to prevent or mitigate that? because you showed a lot of robust techniques, but they are obviously focused on images. So what could you do on a platform like TikTok? Not only because it has a different, it works differently, but also the media that's shared there is different as well. Thanks.
Yeah, that's a very good question. And basically, so for TikTok, I don't think that TikTok has a big hateful, at least from my experience, it doesn't have a big hateful problem. But the problem with TikTok is more what I will call subtle types of extreme content. You know, I mean, you might have, you know, things that are promoting eating disorders or things that are promoting self-harm and so on. So I don't necessarily think that TikTok has a hate speech problem, but it has some other problems that might affect our society, especially because TikTok is very popular for people younger age, you know. And for the second part, that's a very good question that I'm also trying to figure out, you know, how can I apply AI models on TikTok, because, you know, it's a video format, so there are a lot of challenges there of how to basically extract semantics from videos and associate it with other metadata. So yeah, I don't have a good answer to that, you know. It's something that I also actively think. So yeah, thanks.
One more question.
Hey, Savvas, thanks for the presentation. Here's the question that we were kind of wondering over here. One way or another, we do have a latent space that correlates words with images, right? Like there's the only way to establish those similarities. At that point, how is CLIP any different than, for example, grabbing the latent space of a generative model? And, you know, maybe we could take the prompt, like the text prompt, put it on the model, grab the latent space, like the middle section of the model, for example, do the same thing for the image that you're trying to establish a correlation to, and, you know, try to identify the image that has the closest latent space using those generative models. Is CLIP just you know, halfway through the generative model, or is it fundamentally different?
I mean, you can always do the same thing with generative models, right? So you can do it. I mean, with generative models, you do the same thing, where you basically give the prompt and then you obtain the intermediate representation, or you treat it as embedding. But the difference with CLIP is that you don't have any generative part. You simply use this image and text encoder, you train them on the ground truth. The ground truth is what? The ground truth is the image text pairs, and you simply map these things to the same vector space. I think you can do the same thing with what you suggested, but I don't have a clear picture of how different it will be, you know. The only thing that comes to my mind is that here you are you are not relying on anything generative, so you have real data from the web, you know.
Okay, that makes sense. Thank you.
One last question. Okay.
Hi, Professor. Thanks for the lecture. And I don't know if I'm right, but I think that in the social medias, in a lot of spaces in the internet, hateful memes and hateful discourse go around, and a lot of people view them. And I want to know why, like, the big techs and the companies allow this type of thing happens. Mm-hmm. Why they are negligent in that topic?
Yeah, that's a very good question. I mean, so from their point of view, what they will say is that we are trying, but the problem is very hard, you know. So that's what they will say. But on the other hand, we have to keep in mind that they are also not very, they're not very incentivized, you know. So they will not really earn money if they moderate or remove hateful content. So I think, yeah, going forward, there is a need to basically have better regulations, which is basically what this Digital Services Act is trying to do, because what it's trying to do is basically keep accountable the platforms for what happens for allowing hate speech and all these things, you know. So yeah.
Okay, we have time for one last question, and I have that question. So, Savvas, I was wondering if this data donation, by the way, this data donation strategy, I already told you this is a very smart idea, very interesting stuff. I was wondering if you I was wondering if this kind of data allow you to hint on something about moderation. I don't know exactly what kind of data you have, but usually moderation is something that the companies do to, you know, let's think about TikTok, right? To preserve the system, but it's something they keep as a secret. They don't explain if the person, how many people are moderating, and when they moderate political content, it's complicated, right? Because it could be removed more things from one side or another. Of course, they focus on hate speech and so on, but they don't tell too much. It's like a black box. You don't know even the amount of people who works on those things. So, any idea from this kind of data about moderation?
So I don't think that this data can be used for moderation, because it's only, it's basically the data that you obtain for each user is bounded to what the user did on the platform. So what you watched, what you shared, what you liked. So there is nothing about moderation, you know. So the only thing that you can potentially try to understand is based on these traces of all the videos that the user watched. Which of them are available or they are moderated and so on. Only that. But there is nothing about moderation. And the other thing about moderation, I mean, these platforms also release these transparency reports, which is basically aggregate data of what efforts they did to moderate content. But the problem there is that you don't know, you know, how accurate these reports are, because, okay, they say we removed 95% of hate speech, but who knows, you know?
I read the one about the Brazilian election. It was like, we removed this amount of videos, they were viewed by this amount of people. They give a bunch of statistics, but you never know how effective that was, what's the size about that thing represents of the overall thing. Yeah. Okay.